So it's a great pleasure and honor to have here Gianpiero Gallo, who is a very well-known econometrician. He contributed to many sides of econometrics, but probably the most recent important part is the one about financial econometrics and volatility models. He collaborated with the greatest persons in time series analysis, and so I'll just leave the stage to him. Thank you.
Okay, thank you, Matteo. Well, thanks for having me. It's always a pleasure to be able to present my work, I should say our work. This is joint work with Alessandra, Vincenzo, and Fabrizio, and it's an evolution of a line of research that we've been pursuing for quite a while, I must say. So let me start by saying, if I manage to, oops. Okay. Okay, so this is something that, I mean, in terms of introduction, I'm going to rewind the tape and place where we are now from where we come from. And so in financial econometrics and financial volatility modeling, the original contributions obviously go back to ARCH and GARCH modeling, but the idea here is that there is quite a bit of extra information that we can get out of measuring volatility directly, and the availability of ultra high frequency data obviously favor the stream of literature in measuring volatility, and then modeling volatility comes next. And anything that we've done in line with what Matteo was mentioning, in line with the great San Diego School of Econometrics, comes from some empirical evidence, or some stylized facts that one needs to capture in the models that are suggested. And one particular feature is what this paper is about. We put ourselves in the line of literature about modeling realized variance. We know that that is something that captures market activity during the day. So there is some concern about what happens when you consider also overnight behavior. Then it offers some flexibility because being a direct measure of market activity, you can model variance or volatility or log variance. There are various contributions in this sense. And it's now many years that it's been used to evaluate forecasting performance. So what we do in this paper, it's something that focuses in particular on a feature of volatility dynamics, which is something that you can detect. I'll comment on that with a graphical reference. Is a slow-moving component of volatility. So something that in other papers we've called local average, something that is not constant across the whole period, but sort of gives a long wave in the behavior of the series. So there are different ways of addressing the problem. There is a GARCH world, which I will touch briefly on, versus this stream of literature that originated by Rob Engel's paper in 2002. So we mark the 20th anniversary this year, and we suggest a fairly general member of the family called the Doubly multiplicative error model, where the idea of having two components, one is a short run and one is a more long run, combining together multiplicatively is the essence of what we're doing. And so I will discuss some statistical properties of the estimator and give you some details on stock market indices. In other work, we have directly addressed issues related to specific individual stocks, but that is something that doesn't change much the flavor of what we're saying. So what do we do? Basically, in the paper, we have four characterizations of this long run. The first one is we just ignore the problem. And so we just say that this long run component is a constant, and that is a benchmark model. It's the base multiplicative error model. We can adopt a statistical smoothing technique, and the spline MEM is what is in the most recent version of the paper. And then we have two novel specifications. One is called the component MEM. The feature of this is that it extracts this low frequency component from daily data. An alternative, which stems from some work that I've done with Alessandra Amendola and Vincenzo Candila, is an extension of the mixed frequency approach that is existing in GARCH. We suggested an extension in a number of papers, but here it's the first time that we bring it to the world of multiplicative error models. And so the characteristic of that approach is to have monthly observations, so something that comes directly from, say, macro variables. I'm showing something about using industrial production in the US as a driver of this business cycle related component, or if you want, transmission of effects from the real economy to the market behavior. So just to give you a rundown on the structure of the paper, we have some motivation. Obviously, we do the background check in terms of justifying why we're interested in this new component, the MEM and MEMMIDAS, so that these two members of the doubly multiplicative error model. I'm not going to go through, although I have them in the slides, I'm not going to go through the estimators properties and the statistical inferences. Fairly heavy, but it has some interesting features that I'll touch on, at least in general terms. I'll mainly focus on the Standard & Poor 500 realized volatility. There are a few others in the paper, and I'm going to give you a comparison. That is the part that we've been struggling with, because there is something that is quite familiar to people that work in more complex parameterizations or more complex models. You get very good satisfactory in-sample behavior, and then when you go out of sample, something simpler probably is more than enough. And Fabrizio and I have paid some attention. We discussed this issue, and I'm going to show you some results that we got and some ideas for how to address the problem. So we're not going to throw away the more complicated models because of other simple models performing as well out of sample, but we want to pinpoint these features. So there is a large list of models that we call into action, mainly because we want to also, so one of the contributions is to say, well, is this modeling directly realized volatility something that goes beyond what is the traditional approach of taking returns and modeling the conditional variance of returns in a GARCH environment with some modification in the large family of GARCH models. So let me just backtrack a little bit. Of course, these are very familiar, is a very familiar setup for GARCH, has been around for many years now. Basically, the idea is to have a double equation, one for the mean of the returns, the conditional mean of the returns, and the other one is the conditional variance. And the conditional variance is seen to behave autoregressively, so it has some reaction to recent information, and out of that there is an evolution that has some persistence and captures those features of volatility clustering that we have been exposed to again for many years now. The point that I call the attention on is the fact that there is no major loss in assuming the conditional mean irrelevant. So thinking of a conditional mean that describes the evolution of returns and to some extent manages to predict returns is something that gets obviously frustrated by the reality of market efficiency and the fact that any possibility of, at least in the short run, making systematic gains or profits is obviously not there. So by making irrelevant this conditional mean, we are left with the model for the conditional variance becomes a model for the conditional expectation of squared returns. So the square returns now have a multiplicative error structure. That is, there is a conditional mean, well, the conditional mean of square returns. So it's a conditional mean. And then you have an error term that is IID, and hence from an expectation perspective, there is no content, no predictive content. So what do we get here? We get that this error term squared has to have a unit mean. And we also need, given that it is explicitly squared, a term that needs to have a non-negative support. So the idea is that we have multiplicative error, yes, and everything is for non-negative value processes. So this is something that starts from square returns, but then extends, and that is where we went next, with a contribution by Engel and Russell in 1998, where they took financial duration, so movements of prices get recorded in high frequency, and the time elapsed between trades constitutes duration, so a process that once again, that is the contribution by Engel and Russell in 1998, is affected, quote unquote, by clustering, by persistence. So intensive, so short durations tend to be followed by short durations, and longer durations tend to be followed by longer durations. So market activity measured in a different way, measured at the intradaily level. So it's high frequency. And at that point, Rob was a conference in the year 2000 in Australia, came up with this generalization and said, well, you know, at this point, we know that it works for returns. For conditional variance of returns, it works. It works for durations. It should work, and it will work also for other indicators of market activity. So absolute returns, fine. But realized volatility, those were the early years when measures of volatility coming up from 5-minute returns intradaily were available. Volume, range, number of trades, bid-ask spreads. Those are all processes that are all non-negative. Some of them have zeros. If you need me to mask myself, I can. All right. Okay, so the point that is important here is that if these processes can have some zeros, the main consequence or the main casualty is the fact that you cannot take logs. So you cannot linearize the model. You cannot work some other way. I mean, for volatility, of course, it is possible since volatility is never going to be equal to zero. But in general, we prefer this representation because it gives you directly the movements in the variable of interest and not in the log of the variable of interest, even if that is possible, that log transformation is possible, because then any predictions that you get in terms of logs, you take anti-logs and you have to evaluate what type of bias you are putting in. So very briefly put, univariate MEM, we said we are inspired by stylized facts, so we have the base MEM, then we have a further reflection on the theme, further thoughts being put and seeing that other variables could be relevant in modeling the process of interest. And now from the stylized facts that I'm going to show you in a moment, we come to the doubly multiplicative model, in which there is this extra term, this tau t, that we take to represent as a symbol the low frequency, the slow moving component. So volatility is measured directly. The fear index is very well known now. Many other exchanges, this is on the Standard & Poor 500 and is option price, so implied volatility based, the sort of average of 1 month implied volatility is on option prices. This has been the benchmark when you want to connect it, and I took it from what I call to my students Uncle Fred, so the Federal Reserve economic data with a sort of natural superimposition of the recession time. So you see that the spikes of volatility come together with the gray areas of recession. Realized volatility, so something that is related to the, it's a different way of measuring volatility, obviously, and it comes from, this is a kernel, one of the many incarnations of the volatility. This is something that I took from the Oxford Main Institute library of realized volatilities. So here we have the realized volatility series in annualized terms on the top panel, and in the middle we have the corresponding returns. And so there is this usual idea that I didn't want to do that. It's okay, I'm not going to do it. it's misbehaving. Okay, not gonna touch it anymore. It seems like it's not my fault. Okay, I'll try to share it again. Okay. Okay. Not gonna work. Never happened to me before. So I'll keep on going to maintain myself in a time limit. So various approaches, and I'm going to go quickly so that I don't get stuck in introducing the various features. So we have one idea is to have an extension to what Engel and Lee suggested in 1999 in terms of the component GARCH, where you have a permanent with a high persistence component and a transitory one, and that is something that was extended to the MEM a while ago, and it provides a decent amount of fit. When you get to the GARCH, so if you bring in terms of what I was mentioning before, if you bring in a comparison between the performance of GARCH and the performance of MEMS, both of them can be specified to accommodate these low frequency components, so this long-term, long-run volatility. So the GARCH pays the price of going back to the returns and not exploiting any high frequency information with some qualification, because you always can bring in the predetermined variables that I showed you before in terms of even lagged realized volatility. Is the idea behind the realized GARCH of Hang Seng. And in the MEM, you explicitly consider these two components. One is the short term and the other is the long term component. In the GARCH world, I would refer you to the review paper by Amado, Silvenonen, and Terasvirka, where we have a variety of approaches. One is a non-parametric one. One is the non-parametric approach that Engel and Angel put together. This and all the other methods that I am suggesting here have a good side effect, a good byproduct, because you can always bring back some analysis of macroeconomic determinants of volatility. This is clearly something that is done ex post in a sort of descriptive / explanatory fashion. Then you have something that goes under the umbrella of smooth transition, and that is the stream of literature that Cristina Amado and Timo Terasbetta put together. The Markov switching approach, where rather than having a smooth behavior in this low frequency component, we have average levels of volatility that change by regime. And Tauti, and I'll show you an example in a moment, will give you a step function, and you end up approximating this long wave with these steps. In the GARCH-MIDAS, there is yet another way of approaching the problem, which is you take this Tauti, this low frequency component, you make it a function of past observation of data. But the peculiarity there is that if you start from daily data for your main process of interest, you end up exploiting, say, weekly or monthly data. Let me go quickly, given that time is running. The GARCH-MIDAS has this sort of standard specification. There is something that in the paper with Alessandra Amendola and Vincenzo Candila we introduced as a sort of modification and extension. But the basic idea is that you have something that moves by month, and that combines with something that moves by the day. Other ways, well, Eduardo Otranto and I have done some work in terms of market switching, smooth transition. These splines date back on the work with Christian Brownlees and another paper with Marigozzi, Brownlees, and Veredas. We extract this common smooth factor from a large panel of realized volatilities. So, long introduction to say, to justify the fact that apart from the details that I will shortly give you, the idea is, the question becomes, does this low frequency component provide you with some extra and relevant explanation of volatility, so in terms of in sample fit, and does it give you something in terms of forecasting performance? So let me go to the idea that, Brian De Palma's Carlito's Way shows you right away the end of the movie. And so I'll show you what we get here. So we show the bottom line at the very start. And the very start is that in providing a description of the evolution of the monthly aggregated realized volatility. So here we are moving the granularity of the graphical evidence to a monthly basis. We manage with this low frequency component estimated with this, I believe, is industrial production in the US. You get a very good fit in sample. So this is promising. Another way of, I told you, you could characterize the same thing, is this average level of volatility that moves not all the time, but moves across regimes. Okay, that is something that has proved successful in following Jim Hamilton's work in in the study of business cycles, but it applies also in this context. So what we do here is we start from the composition of a traditional MEM models in order to highlight the presence of what is a short run or a short-term volatility component that moves around a constant. This is the base model. So the base model is characterized as a flat line around which you have some dynamics. Can we improve on that? The answer is, well, we claim yes, with this double component. And the question now becomes, and that is what is in the paper, how do you perform the specification of these models? The first one is something that looks a lot like a GARCH, apart from the fact that the constant term is specified a little bit differently because you want these components to be identified. So if you have a target, which is the level of volatility, then everything else needs to move around one. So you should interpret these components as a sort of amplification or dampening factors that go above or below this long-term component. The fact that in bold you find extra terms tells you that we can make this model general in that it can react to other market activity variables in the same time scale as the main variable of interest. So in there we could put in, say, volume. So we could put in something else, number of trades that could explain volatility, taking market activity from a different perspective. The component MEM takes the tau t, as I told you, with daily data, and it projects it in taking a different transformation of the data that focuses on something that should be moving more slowly. So we have this as one of the contributions of the model. The other one is the MEMMIDAS that parallels the GARCH-MIDAS. So I said I'm not going to give you extra details on that. The point is that the mixture of frequencies that relates and the choice, what becomes relevant is the choice of what variable, what macro variable you're putting in. So industrial production is the choice, but you can have indicators of sentiment about economic activity, so something that is more forward-looking. So there is a wide array of choices ahead. Let me skip all this part that relates to the estimation procedure and properties of the estimators, just to be summarized, the fact that instead of or next to maximum likelihood, you can derive an estimator that is based on a generalized method of moments. The advantage of that is not to have to choose one parametric distribution for the error term. And so the other is that in a multivariate, I won't have time to talk about it today, but in a multivariate case, multivariate distributions for non-negative valued random variables are difficult to come by. One solution I'm looking at, Andrea, is obviously a copula function approach in there. Obviously, he can tell us several ways of addressing the right way of taking advantage of features in the data. So let me skip to the empirical analysis. As I said, the ambition is to say, we take the GARCH world and we model returns. So we take the MEM world, or rather the realized volatility world, and we use our MEMs, but we also use the HAR, the heterogeneous autoregressive model by Fulvio Corsi, and we run with usual horse race, and we see what comes out. This is way too detailed, I think. I don't see anything not having a large screen, but believe me, there is a list of specifications of various models that are used in the paper as summary and homogenization of notation to pinpoint various aspects that each model captures. We are taking a sample that is fairly large between January 2001 and May 15, 2020. So at the end, we have some activity coming from the eruption of the pandemic, but obviously in the revision that we are undergoing, we need to extend it to see the sort of the down wave of that spike in February, March. So this is the data. We get all that we need to see here is that models are by column, and the gray part that you see at the bottom, according to two loss functions, the Q-like and the mean square error, tell you what enters the model confidence set. So this is very reassuring and very encouraging, because in sample, not only for the Standard & Poor's, but also for the other indices we're taking into consideration, we get our models perform the best. And actually the component MEM for the Q-like is the single quote-unquote winner. What do we get graphically? Well, here we get our four different series. This is univariate. This is all, so the CMEM takes into consideration only its own past, so realized volatility and past realized volatility. There is no attempt at doing some cross, like spillover across markets. So it is a purely univariate framework, which could be extended. And the bottom panel is what you get out of the MEMMIDAS, so with the contribution of the industrial production in the US, with the thought that the industrial production drives to some extent a sort of world business cycle, and the reactions then spill over to the others. But of course, asynchronous business cycles could be taken into consideration. We just wanted to keep it simple for comparability. The commonality of, so here I focus on the bottom panel and I put it together on a shorter period between 2001 and 2012, is that in spite of the fact that there is the same macro variable, so the industrial production, you get a very high correlation between these components, which are, I remind you, are estimated separately, so they don't see the common information if not exposed as I'm showing you here. Yet we have a very high correlation coefficient between these series, which makes us think, well, there is a possibility of capturing or trying to capture some factor structure behind this. tragically so, when we go out of sample, the gray spills over and covers many models at once. Here we run what is a mixed blessing. So you get to divide the out of sample period one by one, 1 year by 1 year, and see what you get. And sometimes, I mean, it's reassuring once again that the component MEM in particular, the MEMMIDAS a little bit less, is always present in a model confidence set. So you get the idea that competitors, yes, numerically perform, one performs better than the other, but statistically speaking, when you put in some sort of confidence interval around that, this is the idea behind the model confidence set, basically they become undistinguishable. Jokingly, on Twitter yesterday came out that the idea of this top 5 journals, and somebody put together a model confidence set for the top 30, and only the QGE comes up as consistently being out of the, they put it the worst 25. So by rejecting the QGE being in the bottom 25, automatically it enters the top 5. But what enters in the top 5 is open to question. That is the part of the curiosum around talking about this madness about the top 5 and how bright you are if you are in that, and how stupid you are if you're not. But I see that Aristat seems to be peaking up. Anyway, here I'm bringing you some evidence fresh off the press, because this is a revision that Fabrizio and I sent off on Sunday, and it's a paper in which we yet give another twist to this idea of the low frequency component. What you need to pay attention to is the fact that this SP, which is yet another model, is a slow moving non-parametric fit. So it's like a spline that is not a spline, performs very well in sample. And then when you bring it out of sample, so the bottom line SP in both MSc and QLike does disastrously. Okay, so it's beaten. This is the reference of the comparison with the base MEM model, so without any component. And we asked ourselves what is going on, and I provide the graphical evidence, so the zoom that we brought in. And what you see on the left-hand side, and we just kept it simple, saying this is the slow-moving component. We get at the end of the in sample, we need to project that. And once we project that, and we want to be parsimonious in the effort of re-estimating the model, this is the most extreme. We don't re-estimate the model and we keep it running with the same parameters for the rest. We get a systematic bias in the sense that the series has a lowering of the local average. The model with the spline or with the non-parametric component still thinks that the average level of volatility is much higher. And so systematically it's outperformed by some, it looks a little bit like the fable of the hare and the tortoise. The tortoise goes slowly, but more consistent or more reliably to the target. So what do we get? And I close. Yes, we have completed to a certain extent. So the general framework of various contributions in the GARCH family and the MEM family. So this is where our doubly multiplicative error model comes in. but there are many open questions, obviously. A few questions. Is a long-run component advisable? I would say the answer is yes. Mainly, I would say, if we want to give some interpretability of what goes on between the real world, quote unquote, and the financial world. So this idea that there are things that move slowly and they are related to the business cycle, in my view, in our view, is something that is a value added. Then the second aspect we take into consideration, should we model realized volatility rather than going down the secure road, safe road of GARCH? Our answer is still yes. So intraday information gives extra mileage relative to just considering the returns. We are favoring in a comparison between the HAR, the multiplicative approach. In another paper, we have seen that the MEM is robust to measurement errors in volatility and the HAR is less so. And it comes from the fact that automatically the multiplicative error model structure captures some heteroscedasticity that is relevant when we consider measurement errors. 2 more minutes to say that we have a variety of ways of addressing it. So we're not claiming that one specific way dominates the other, because what I've been talking about, parameter instability, obviously could give a prize to one model in a certain period and not in the other. So this calls for probably some forecast combination techniques, so something that explores how different features could be captured by different models. So we have other variables that could be introduced in the monthly MIDAS, and there are many contributions, recent contributions that give us some hints of where to go. Sorry, I took a little longer, but there were some random disturbances to the presentation.
Thank you. Maybe, Claudio, you should manage the questions on Zoom.